Hello everyone, welcome to the session on design and analysis of algorithm. In this session, we are going to discuss how to analyze the algorithm. So as we know that in the previous session, as we discussed, for a single problem we can have multiple solution. So among those multiple solution, we need to obtain or we need to tell that which is the better algorithm. So how quickly the algorithm works. So in order to tell that, we need to find out the time efficiency. So in order to find out the time efficiency, we need to analyze the algorithm. So therefore, how we are going to analyze and what are the steps for analyzing this algorithm, let us see. So here, as I said, in order to analyze or in order to find out the time complexity of any algorithm, we need to think on two important terminologies here. One is the input size whatever we have given to the algorithm, and one more is the basic operation of the algorithm. So let us based on these two only we are going to calculate the time complexity or we are going to analyze the algorithm. So let me write the algorithm steps. So basically here we have 5 steps for analyzing the algorithm. The very first step is, so here we need to identify the parameters based on the inputs size. So for all the algorithms we will be having the input, so that is the thing. And the next step is we need to identify the algorithms basic operation. Okay. The second step is to identify the basic operation, and the third step is to find out, so we need to check whether the number of times the BO, that is the basic operation, I am going to use as B dot O, that is the number of times the basic operation executed, is it based only on the size of the input, whether it is based on the size of the input, and if so, so we can calculate the time efficiency. If not, based on input size and also some other factors, if it is depends on the number of times the basic operation executed is based on input as well as some other extra factors, then we need to check the basic operation, the number of times the basic operation executed based on the average case, best case, and the worst case efficiency separately. We need to analyze or else we need to find out the time efficiency in terms of its best case, worst case and average case. Okay. So next one is the fourth one. The fourth, here we need to set up a summation equation to find the time efficiency. Of the algorithm, time efficiency of the algorithm. So next is fifth step is to represent the order of growth of the algorithm in terms of any standard asymptotic notations. So these are the 5 different steps for analyzing our algorithm. What is the first step? We need to identify what are the parameters for that algorithm. That is nothing but the size of the input, whatever we have taken, the inputs we need to identify. So if you have an input and also any other extra factors, that one also you need to identify in the first step itself. And next step is we need to identify the basic operation of the algorithm. So basic operation, usually the basic operation will be in the innermost loop. Okay, and while taking the example, I will explain what is that basic operation is. And the third step is, so the number of times the basic operation executed, is it based on the size of the input or any other extra factor we need to check. So if the number of times the basic operation executed is purely based on the input size, then it's okay, the worst case efficiency only we need to identify. Otherwise, you need to encounter with the efficiency function has to be represented in 3 types. So one is best case, next one is worst case, and another one is the average case. So we need to find out the efficiency in terms of these 3 cases. So the next one is once you identify based on what it is depends. So we need to set up a summation equation. Since we are finding or we are analyzing the non-recursive algorithm, we need to set up a summation equation for the algorithm. And once you set up the summation equation, obviously we need to solve it. Okay, so once you solve it, whatever the resultant equation you get, so we need to take the higher order term of that particular equation, and that term is considered as an time efficiency of our algorithm, and that that can be represented using any of the asymptotic notations. So in order to understand these steps, so let me take the simple example. Okay, so in order to how to identify the inputs, how to identify the basic operations, and then how to check whether the basic operation is how many times the basic operation executed is based on input or any other extra factor. For these are all things, so better to go with a simple example. Okay, so in order to explain this, let me take the simple example like finding the sum of n given numbers. Okay, so a list of n numbers. So usually, so if you consider before we are considering that we will be having n numbers in the sense. So n numbers, how we are going to store this n numbers? Obviously, so either linked list or arrays we are going to use. So let me take the data structure as array itself. Okay, in the array, so we will be having the n values in the array A. So starting with 0, 1, 2, 3, 4. If you say n is equal to 5, so we are going to store 5 different values will be there. Say for example 10, 20, 50, 2 and 3. So unordered array. So n 5 elements are there. So we need to take the sum of these elements. So in order to find out the sum of these elements, what we can do, so here, so usually the operation will be, so how we are going to do the addition of these elements. So if you have only 2 numbers, how we are going to do, so you are going to add only these 2 numbers. Since you have only 2 numbers, you are adding 1 and 2. But here more than 2 numbers are present. By that time what we are doing here is, so we are accessing the array elements using its index values. Okay, so we are going to keep on adding the value to the resultant value. So if you get the result, this resultant value will be added to the next element, and this resultant value should be added to the next resultant value, and then this resultant value whatever we have got, this will be added with the next coming value, the next value that is present in the array. Right. So now if you add these things, so 10 plus 20 is 30, 30 plus 50 is 80, the resultant value is 80. So 80 plus 2 is, the resultant value is 82, 82 plus 4, in the fourth position we have 3, so 3 plus 82 is, the resultant value is 85. So now I need to obtain that value, that is 85. So for this we need to write the algorithm. So now in order to write the algorithm, so this is a simple way we can say, right. So linearly I am taking, so one by one I am adding. So this is called as a brute force approach. So direct approach I am using. So in order to get the sum of n numbers, what I am doing, so I am taking the first number. Usually the first number will be represented using what, the indices value of that particular array. So I am taking the first number, I am adding into the second number, so that is a of 1, and the resultant value will be stored in some variable. Let me call this one as a sum. Okay. So this process is going to be continued until unless you reach the end of this array. So therefore here we need to continuously run or execute this operation. What is that operation? We need to add first and the second number repetitively until unless you reach the end of the list. Okay. So up to that we need to repeat this. So if you are repeating these steps, that is nothing but we need to use the looping statement. Either you can go with the for loop or while loop, it is according to you. Okay. So let me take, so here since we have started with 0th index and ended with the 4, so that is nothing but, so here step by step, in step of what, 1 we are going. So it is better to go with the any looping statement like for loop. So for I starts with 0, in step of 1 we are going up to what, since we have started with 0, so it is, if n is equal to 5, so we are going up to what, 4, that is nothing but n minus 1 time. So if n is equal to 5, definitely this position, that is 4 is nothing but n minus 1, 5 minus 1 is 4 only. So the looping statement should run from 0 to n minus 1. So what is the operation we need to perform? First number and the second number, or else we can say that into the sum only. See, once you add this value, okay, so once you add this value, it will be retained in the sum field, right. So once you add the value, the resultant value will be stored in sum. So this sum, using this sum only, we are going to add the next value. So here we are taking the resultant value and we are adding to the next number, like that we are doing the procedure. So because of that reason, so instead of taking the first number and the second number, I am directly taking the sum. So before that, any number should have, or any variable should have some value. So for that sake, I am going to initialize this value, and then we can have a for loop, and then we can have a operation. What is that operation? We are adding into the sum. So what we are adding? The a of all the indices values. So indices value, let me represent using I variable. So again this will be stored to where? Sum only. So these steps will be repeated until unless it reach the end of the list. So once it is completed, again we need to return back the value. So let me write the algorithm for this. Firstly, algorithm. So I am finding sum of n numbers. So sum of m I am giving the algorithm name as sum of n, and here what are the parameters here? Sum of n numbers, in the sense it should a list having n numbers. So for that list I am representing using some name. So that is array A. So 0 to how many elements will be there? N means 0 to n minus 1 element will be there. Okay. So this is the sum of n numbers, the parameters whatever we are giving, or else you can write like this also. Sum of n, the parameters can be represented as the array of n numbers. So anything you can write, okay, sum of n numbers. So for that I am passing the two parameters. One is the array of consisting of how many elements? N numbers. Okay. So now for this, the purpose of this algorithm is to find sum of n elements. Next, inputs. This is very important. Okay. So input is what? Sum of n elements, in the sense n. So this represents the number of elements in the array. Given list called as an array A of 0 to n minus 1 elements. Okay. So next is the output. So whatever the variable you are using, either it might be result or sum. So whatever the variable you want, you can write it. So obviously here we are finding the sum. So sum holds the value of, the sum of n different elements, right. So now step 1. So we need to initialize the sum, right. So sum is equal to 0, right. So why? Because in the coming lines or statements we are going to use this variable sum. It should be initialized to 0 so that we won't get any semantic errors. So now step 2. So we need to repeat this step, that is sum is equal to sum plus, here I can't say that only A. Okay. So using the indices value only, I am using that value, so that I am representing. So here I have mentioned capital A here, so that I am representing using capital A of, so whatever the variable here we need to write, so that variable I can take it. So in the for loop, so for I starts with 0 to n minus 1. So if you are writing like this, for I starts with 0 to n minus 1, this is understood that. So you need to go from 0 to n minus 1. So here we are not representing the incremental value. So if you want to represent, so by in step of, so how much? So in step of 2, 3, 4, whatever it is, you need to mention it. Otherwise, if you are not mentioning it, that is understood that by default value is, so the incremental value of I is for each iteration is 1. Okay. Then we need to repeat this steps. What is that? Sum is equal to sum plus A of I. Okay. This steps should be repeated from 0 to n minus 1 for the given values of n. Okay. Next, so once it is completed, end for, next step 3 is to return that value. What is that value? The sum value. Sum has to be returned. Okay. So let us trace this. So simple value, so that is n, and n means, so you need to have some array values like 10, 20, 4, 8, 3. Okay, 0, 1, 2, 3 and 4. Okay. So now these are all the values and these are all the indices value in order to access these values in the array, right. So now we have n and the sum. So instead of n, I would like to take I. Why? Because I varies from, so the variable factors whatever we have, we need to take that one. Okay. So here obviously n will be the constant value since I have taken 5 items. So that is nothing but n is equal to 5. Okay. So for n is equal to 5, I am calculating the sum and for the given inputs. Okay. So now I starts with what? 0. So firstly sum is initialized to what? 0. Next I starts with again 0. So I starts with 0. Now it is going to check whether it reached the end of the list or not, right. So for that we are checking whether your I is less than n or not, we need to check. So 0 less than 5 is true. So 0 less than 5 is true. Therefore, we can execute this statement, that is sum plus a of I. What is a of I? A of I value consists of, I value is what? 0. In the 0th place we have 10. So, sum is what? Initially it is 0. 0 plus in the 0th position, ith position. So, now I is pointing to 0th position. In the 0th position we have 10. So 10 is added to 0, its value is 10 now. Okay, the sum value becomes 10. So now again controls comes back here. So I gets increments. So what is I? I is 1. Once I gets increments, it is going to check the condition. So now 1 less than 5. This is also true. Again continue with the same statement. So what is this operation? Sum plus a of I. But I is the variable one. So look into that particular field. So what is the sum now? Updated sum is 10 plus in the a of I. In the first position of a we have 20. So 20 is added to 10. So the resultant value is 30. 30 will be stored to sum. Okay. So next I gets increments. I is 2. 2 less than 5. Is it true or false? True. So next, so into the sum we are going to add a of I. What is I? 2. In the second position of I, we have I is pointing to 2. In the second position we have 4 value. So the value 4. So 30 plus 4 is 34. Next I gets increments 3. So I is pointing to third position. So 3 less than 5 is also true. Next operation is the old sum is 34 plus a of I. In the third position we have 8. So the resultant value is 42, right? 12, 42. Okay. So next I gets increments 4. 3 less than 5. Is it true? True. If it is true, then the old sum, that is 42 plus in the fourth position, that is a of I is pointing to the fourth position. In the fourth position we have 3. Therefore 42 plus 3, that is 45. Sorry. Plus the final sum is, so in that I gets increments 5 and then 5 less than 5 is false. If it is false, then it will come out of the for loop. Once it is come out of the for loop, what is the value that is stored in sum? That is nothing but 45. So 45 is stored in sum and this value will be returned to the called function. This is how we can calculate the sum. The next step is we need to analyze that algorithm. So for analyzing this algorithm or analysis, we can say, very first step. What is the first step? We need to identify the parameters. So what are the parameters here? The input, that is A of how many numbers? N numbers. The size of the input is what now? The size of the input is N. So we have only one input, that is the number of elements, that is N. Okay. Next, do you have any other inputs here? No. So of course the temporary variable is here, the sum, but here this is not the input. Okay, just we have used this to find out the result. Okay, that is initialized to 0. Second step, we need to identify, what is the second step? We need to identify the basic operation of the algorithm. See, usually the basic operation is going to be identified based on the problem statement, or else usually that basic operation will be present in the innermost loop of the algorithm. Okay, so if you consider the problem statement of this algorithm, we need to find out what? Sum of n numbers. Sum in the sense what? We need to find out sum in the sense what is the operation we are performing? Addition operation we are performing. Therefore, what is the basic operation here? So, in order to calculate the sum, we are performing which operation? That is called as a basic operation here. In order to calculate the sum, we are performing addition operation. So that we need to calculate, consider the basic operation as the addition operation. So therefore, the BO or basic operation of the basic operation of the algorithm is what? Addition, right? So what is that equivalent pseudo code or a statement? That is sum is equal to sum plus a of I. This is your equivalent equation, right? So now third step, we need to check how many times your basic operation executed. Is it based on the input size, or else does it based on any other factors? First thing is, this is the simplest algorithm. We don't have any other factor other than our input and the array values. Okay, but here the number of times the basic operation executed means here the operation whatever we are performing, is it based on the input fully? We need to check. That means that here we have an array of 5 elements, right? So if you have an array of 5 elements, have you stuck between any of this array value? No, right? We have started with the 0th position and we have stopped at the last position. The addition, the basic operation is addition. Addition started from the starting point and ended with the last point, or else you can start from the last point also. So by decrementing the values. So I can be start with 4th position and end up with the last position 0. So that, so 4th, 3, 2, 1, 0. So either both the steps 0 to 4 or 4 to 0, whatever it is, all the elements that is present in the array A has been utilized, or else has been takes place in the basic operation, or else the operation whatever we have performed. Therefore, the addition, so this algorithm, that is finding the sum of n algorithm, works for, or else the basic operation whatever we have, that is going to be work for how many times? Definitely it is based on what? The size of the input. So here we don't have any other factor, extra factor. So that is the number of times BO executed is based on only on what? The input size, only on the input size. Okay, so fourth step, what is the fourth step? We need to find out, since it is an iterative algorithm, so we need to set up a summation equation. So now how to set up the summation equation for the given algorithm? So here, whenever we are setting the summation equation, always remember wherever you have written the basic operation, into that loop only you need to go, and you need to, based on that statement only, you need to write the summation equation. Okay, so now here we have a basic operation, sum is equal to sum plus a of I. Okay, on top of this we have a looping statement. So in the looping statement, from where to where that has been done. So that is from 0 to n minus 1 this operation has been performed. Therefore, we need to set up the summation equation to find out the time efficiency function. More or less it is equal to the sum of where to where I starts with 0 to n minus 1. Here how many times your basic, what is the basic operation here? Sum, okay, addition. So how much time it is going to take place? So it is going to take 1 unit of time. Since here we are calculating theoretically, so because of that reason, so here we are taking for 1 addition, so we are taking 1 unit of time. For each iteration it is taking 1 unit of time. So if you have one more addition or subtraction operation here, by that time you need to count the number of operation we are performing. Of course here we are performing assignment also, but here we are considering only the basic operation, that is nothing but addition. So for that, how much time it is going to take? 1 unit of time it is going to take. Therefore, so the number of times, this is nothing but your inputs. T of n is a time efficiency function for the given input n. Okay. So here we have only input n, so that I am taking n. T of n is calculated by setting up the summation equation. Since we have started with 0 to n minus 1, we are performing this operation. So here I starts with 0 to n minus 1 and 1 stands for the how much time it has been taken to execute that particular equation. Of course here we are not calculating based on the machine, okay, how exactly it is going to work. Okay, the computation time here we are not calculating, theoretically we are calculating. So for that reason we are taking that one as a 1 unit, that's it. Okay, so here we are not mentioning whether it is a seconds or milliseconds, whether it is a nanoseconds, we are not mentioning that. Okay, so 1 unit of time it is going to take to execute what? The addition operation or to perform addition operation. That's why we have written 1. So now we need to solve this equation to get this T of n, that is the 5th step. So in the 5th step we need to evaluate this summation equation. How to evaluate this summation equation is, so here for summation equations we have multiple formulas and standard rules. So based on that rules and formulas we need to solve this summation equation. So now here in order to solve this, here we have a constant term, right, 1. So if you have a constant term for any summation equation, then we are going to apply the equation, that is upper bound minus lower bound plus 1. So remember this equation, sum is equal to 1 to n if you have this, and if you have any constant value, by that time in order to solve this equation we are going to make use of the formula, that is upper bound minus lower bound plus 1. Remember this. Okay. So in order to solve this equation we need to use that equation or a formula. Okay. Now let us solve this equation. T of n is equal to sum of 0 to n minus 1, 1. So let me write it again, 1. So this can be written as what? Upper bound is what? N minus 1 and the lower bound is what? Minus 0. And so here you have 1 only because of that reason we are writing plus 1. No, it is not like that. So whether you have a 1, 2, 3, whatever it is, but you need to write what? Plus 1 here. Okay. So plus 1. And if you have 2, 3, 4 here, okay, by that time you need to multiply the entire thing with that constant values. Okay. So now plus 1 minus 1 get cancels, you remaining with what? N. Therefore, what is your T of n? So T of n is equal to n times. So that is nothing but the time efficiency of the given algorithm is n times. That means that for the given n inputs, the basic operation is going to perform for all the n times. Okay, this is how we can analyze the algorithm for the given any kind of problem. Since it is a iterative algorithm, in the fourth step we need to set up what? Summation equation. So how to set up a summation equation? It is based on what? Where the basic operation is present. So we need to go to that basic operation and we need to take the the for loops that is outside the basic operation, and we need to set up and we need to solve that equation, and we need to represent in some asymptotic notation. Since this algorithm does not have best case and average case, so usually we are going to represent in big O notation, big O of n. Okay, and also in the equation we didn't get any factors here, constant factors here. Okay, so this is the highest order polynomial equation of this equation is 1 itself. That means n times. So t of n belongs to big O of n. So it is going to take all the input values and it is going to perform the basic operation for all the n times. Thank you.